Next, we'll look at ways to make the deployment to your device easier. I showed you how to use SCP, the Secure Copy utility in Linux, to copy your files from your development computer to your device. Now, if a person wanted to, they could stick to this workflow throughout the entire development cycle. You make a change to your code, you jump to the console, you type the command, then, often in the second console window, you SSH to the device so you can execute the new code using Node. It would be much better, however, to employ one of the following techniques for automating this deployment cycle. We're going to cover using Intel's IoT XDK, Git, using NPM, and finally, Gulp. Then we'll look at a utility that I wrote for Gulp called Candyman, and we'll see how the whole process can be automated in Visual Studio. Intel, who made the Edison, made an IDE called the Intel IoT XDK. It was Intel's intent to make the authoring and deployment of code simple and seamless, but unfortunately I'm not a fan. The user experience in the program is initially unintuitive and subsequently awkward. I gave it a fair shot, but then I started looking for an easier option. One way to automate your deployment is to use Git. Git is a distributed source control system that I'm sure you know has become incredibly popular. A distributed source control system is essentially just the ability to track changes to a repository of files, and then to keep the files and all the changes in sync with other repositories, including online repositories that may act as a central repository and with repositories on other developers' machines. So it's not too much of a stretch to see that Git can be used to get your working directory project files over to a system that happens to be an IoT device. When you work with two standard Git repositories and you want to push from one to the other, you need to make the target repository a quote-unquote bare repository. Bare as in naked, not bare as in gur. I'll let you search online to figure out how to do that, but it's really not hard. Basically just one line of Git code. But then a bare repository doesn't contain the working files like a regular repository does. So to make this work, you'll have to create a hook on the device that fires whenever some code is pushed to the repository on the device and copies the files out to the deployment location. Now, personally, I'm not a big fan of this method for a variety of reasons. For one, it's using Git for something that it's not exactly made for. It works, but it just doesn't feel quite right to me. Second, the hook requires that you write some Linux shell scripts, and that doesn't sit well with me either. Shell scripts aren't that hard, but I don't know, it just doesn't feel right. And finally, it requires that I change some code and then commit and push it. Oftentimes when I change a bit of code and I want to see my IoT device light up with some new changes, it's not something I really want to commit. It's just something that I'm trying. I know that's a philosophical matter, but there you have it. So since I'm not so into this method and I'm the author, let's move on. Another tool for moving bits from here to there is NPM. You may know that NPM is the Node Package Manager. It gets installed with Node.js, and it's the means by which you discover, install, upgrade, and uninstall Node.js packages. NPM has a central repository or registry of modules. This is where members of the Node community publish modules for others to consume. So if you'd like, you can hijack this bit moving cycle and use it to get your code to your device. This time, instead of going directly to the device like we did with Git, we're going up to the internet, to the NPM repository, and back down to from the internet to our target device. Now, I dislike this method somewhat less than the previous, but I still don't love it. The usage feels much more in line with what the tool was actually created for. Nevertheless, we're still committing small changes, and when each iterative change may really just be a trial. Additionally, it oftentimes doesn't make sense to put projects in NPM that are of no benefit to the Node community. The recent NPM private modules offering could be used, but then you're having to pay. Now, unlike the previous method, and the next one in fact, this method does require that we remotely log into the target device in order to run the npm install command to pull down the latest code. It also requires an internet connection. So let's keep this one in mind, but let's keep looking. The third and final method I'm going to talk about is the one that I happen to prefer, and that's using Gulp. Gulp is a task runner, a workflow automation tool that's really quite wonderful. You may have heard of Grunt, or more likely you heard of the two of them put together, like you could use Grunt or Gulp for that. I find it hilarious, by the way, that the two tools, which do almost the same thing, seem to be in nearly perfect suspension, with neither one yet winning the standards war. I consider Gulp to be the inevitable winner, though, having the clearly massive advantage that the tasks that it runs are really just JavaScript. It allows the utmost of freedom, in my opinion. The main reason that this method is my preferred is that this is exactly the type of scenario it was designed for. There are a few tasks that need to be done each time you build your project, and sending the code to its target device just happens to be one of those tasks. So let's look at how to use Gulp for this task. Remember that fundamentally, we're just trying to get some files copied from the host computer to the target device, and we can use SCP for that. Now, there are various Gulp task plugins that are intended to use SCP as such, but I had a hard time finding one that worked well on all accounts. One didn't allow deep copies, that is, copying all of the nested directories. Another didn't work well with a Windows machine as the host. And yet another one simply had a bug that I didn't feel like taking the time to fix, so I just wrote my own. We're going to talk about that next. Candyman is available in the NPM registry. It's also available open source on GitHub. It's not restricted to use with Gulp. It's simply a tool for defining and executing console commands either locally on the host computer or remotely on one or more target devices. The really nice part is that it allows you to configure one-to-many hosts, or actually one-to-many target devices. And each of those in turn is going to be treated as the target device and effectively allows you to distribute your code to many devices without any extra effort. This works really well for when you have an army of peer IoT devices that all run the same code. The real value of Candyman, in my opinion, is the two asynchronous functions that allow for the local and remote command executions. Beyond that, I've implemented a few commands, but you'll likely want to customize this for your own use. One of the tasks here that I'd like to note is the set startup. So far, we've been jumping to the device to execute the code, but when you finish your project, you'll likely want to install it and make it so that restarting your device results in your code running. If anything goes awry, you want to simply hit reset and know that it's going to start over running your code. That's where the set startup task goes in. This is going to create a startup file using the latest and greatest systemd service in Linux. Even Debian and Ubuntu have decided to adopt systemd for services, so once again we've got a standard and we can all go to work. The cool thing about Visual Studio is that it actually enables two of the three methods that I've lined out. It has a really good interface and engine for Git integration, so after you set up a bare repository on your device, you'll have no trouble committing your code and pushing it out. It has good NPM integration too, but I don't think it has a means to publish an NPM module through the interface. And of course, you wouldn't be running Visual Studio on your device in order to pull down NPM modules. This doesn't exactly feel like a missing feature in Visual Studio, it's just something that doesn't necessarily belong. Now finally, the support for Gulp in Visual Studio is really good, and it facilitates a really good workflow. The Gulp tasks that are defined are recognized by a plugin in Visual Studio 2013. It's built into Visual Studio 2015 and beyond. And you're then given the option to map those tasks to the before build, after build, clean, and solution open events. So if you map the Gulp deploy command to your after build event, then suddenly building your solution, or using the keyboard shortcut Ctrl-Shift-B, results in the code actually going to the device. I'll show how this works in a subsequent clip. I do want to point out first, however, that you could even use the watch function in Gulp to trigger a code deployment every single time a file in the file system is changed. That's some really good and granular control.